Hello everyone, welcome to video lecture series on statistics and numerical method. This is Dr. Prabhakaran, working as an assistant professor in the Department of Mathematics, St. Joseph Institute of Technology. And in this video lectures, we are going to see the Newton-Raphson method. This is actually part 2 of, already we have taken the Newton-Raphson introductions and then we have solved the sum of the problems in which, and this is just an extension, and then another, that is in the application point of view. So that is finding out the square root of any positive integer or reciprocal of any integers. If you just curious about this, how we are finding out the roots of a equation, right? In a scientific calculator we are just putting root of some numbers, we instantly we are getting, but at the back end this is the numerical methods. They have algorithm created, based on that only we are getting the answer instantly. And we can have a doubt that why we need to know that these things means. Without knowing, without aware of that, we are just utilizing the things, Newton-Raphson method. But this is what the foundations for finding out the square root of any number and moreover reciprocal of any number. So we'll go with this. So as I said, first we are finding out the square root of any integer using the Newton-Raphson method, and next we are going to find the reciprocal of any integer. So before entering into that, we'll recalculate things. The formula derivations already we have seen in the previous video. I will quickly see the things how we have derived the formula. And then next we can move further, finding out the square root of root 15. First we have to derive the general formula for root 15. So first we have taken the function in which we have taken the draw tangents at the point xi, and then we have derived the formula, and then this is for the first tangent, and then with reference to the next point again we can go for the tangent. After a certain stage it's going to converge the solution. This is what we have derived, and this is a xi plus 1 equal to xi minus f of xi by f dash of xi. This is what the Newton-Raphson formula for finding out the roots of any equation, that is maybe transcendental equation. If you want to write it more precisely, xn plus 1 equal to nothing but xn minus f of xn f dash of xn. Because we are using n for generalized case, n can be run into 0, from can start with 0, 1, 2, 3 based on the problem. So we can move further, finding out the square root of any integers. First, or what is the ultimate aim? Square root, right? That's what. So we are trying to find the square root of any integer. I'm representing n for the integer, so that you can take the value. Our ultimate aim is to find the x equal to square root of any integer. Maybe we are representing on x for the unknown values, right? X equal to square root of n. So we have to make it as a, if you want to find the roots of equation, zeros of equation means we can convert the equation in terms of the function which is equivalent to 0, so that we can take to the left hand side root n to the left hand side. Before that we can square on both sides. By squaring on both sides, we can instantly get x square equal to simply n. Now we can go for a simplification. X square minus n equal to 0. So we can brought it in terms of in formal form, right? This is, we can take f of x equals 0, so that we can go for solving the equation, that is for trying to finding out the zeros of the equation. If you consider this as f of x equal to x square minus n, then we can go for f dash of x. So x square is 2x. Since n is an integer, it's going to be constant, right? When you go, constant value is nothing but 0. So this is 0. So simply f dash of x equal to 0. This is what the things. So first we are going to derive the general formula for finding out the square root of any integer, right? So that we can go for the generalized case. So we know that Newton-Raphson formula, that is nothing but xn plus 1 equal to xn minus f of xn divided by f dash of xn. So xn plus 1 equal to, this is what the generalized formula. Next we can move for solving. In this particular problem, f of x equal to xn square means f of xn is nothing but xn square minus n, just replacing x by xn. Furthermore, f dash of xn is nothing but 2 times of xn. We are going to substitute here and we are trying to derive the generalized formula. That is xn plus 1 equal to xn minus, that is since, sorry, xn equal to, since function is, I'll write it here so that you can quickly connect with this, xn square minus root n, f dash of xn is 2xn. So substitute here xn square minus n, right, that is 2xn. So this is what the formula. But so in mathematics usually we are going to simplify the things, right? We are trying to bring in the formal structures. So other things are just a simplification. If you are not, if you are comfortable with this, means you can keep this. This is what the generalized formula for finding out any square, finding out the square root of any integers. But we are trying to simplify further. Take the LCM. This is going to give us 2xn square minus xn square minus n by 2xn. Furthermore, 2xn square minus xn square is nothing but xn square minus n by 2xn. And simplify further. 1 by 2 take it out and again split up xn square by xn minus n by xn. This is going to give us 1 by 2 xn minus n by xn. This is what the generalized formula for finding out the square root of any integers. So our ultimate aim is to find, so this is generalized formula for square root of any integer, as I said, right? Maybe a square root of 11, square root of 12, square root of even 4, square root of 9, whatever it may be. But in this problem they were asked us to calculate square root of root 15, that is square root of 15. So whereas n value is 50, we can go for starting the iteration. From this, if you go with x1 means 1 by 2 x naught minus n by x naught, right, for the first iteration. So that we know that the n value is simply 15, we can replace the 15 here, but we have to go with initial value x naught. We have the square numbers, just look at it in the left side of the screen. 2 square is 4, 3 square is 9, 4 square is 16. In the reverse, if you go with the reverse, root 4 is 2, root 9 is 3, root 16 is 4. But they are asking in between, root 15, the root lies between 3 and 4, right? So the answer is going to be lies between 3 and 4. So we can take the initial point as either 3 or 4. That's our wish. So that from this, since root 15 is nearby root 16, I am going to take x naught as a 4. So let x naught equal to 4. So that the function is going to change as x1 equal to 1 by 2 4 minus 15 by 4. The answer is 3.8750. This is x1. Again, when you go for the next iteration, x2, this is what the generalized formula, x2 equal to 1 by 2 x1 minus 15 by x1. Just now we have calculated the x1. You can show As we seen in the previous lecture, you can make use of the scientific calculator also, but this is the very easiest one. You can go with the manual calculation. So 1 by 2, 3.8750 by 15 by 3.8750. x2 we are getting as 3.8730. Again, when you go for the third iteration, again the same logic, 1 by 2 x2 minus 15 by x2. So replace the x2 by 3.87. Just pause the video and try it for yourself. I'll give maybe with 30 seconds you can calculate. It's very simple, right? Just replace x2 by 3.8730. What you are getting? So just try it. I hope you are all following the things. 3.87 check whether you are getting the same things or not. So just compare second and third iterations are same. We are getting the same values, so that we can stop this iteration. We can terminate the process since we are getting the same value. This is what the solution for the given equation, that is given solution for the square root of 15. So similarly we can go for finding out the square root of 17, square root of 19, square root of 9 we can know that, square root of 16 we know that, but if it is not a square number, means by using the Newton-Raphson method we can get it very quickly. So we can recap the things, what are the things we have seen so far. We have taken the function, we have simplified f of x and f dash of xn, and then we have applied in the generalized formula, and then we have simplified, we have brought it in terms of general form, and then in which we have taken the initial point as a 4, because root 15 is closer to root 16. That's why we have taken root 15. We have started the iteration process in which second and third iterations are same. The same things you can use the scientific calculator by feeding the value, that is 1 by 2. So simply you can 1 by 2, you can, if you go for a scientific calculator, means just simply type 1 by 2 and open the bracket x plus open the bracket 15 by x close the bracket, and go for the calc function, calc x equal to the initial point x naught as a 4, right? Put equal, we'll get the answer as 3.8750. Similarly again press the calc function and it will ask the x value, so simply put 3.8750 and by entering equals you can get the answer 3.8730. Again use the calc function, it will ask the x value, so simply type 3.87330 and it will give the answer as 3.8730 instantly. So by using the scientific calculator, very easy, but when you are giving the input to the calculator, we must be careful. You have to use the bracket more carefully, that is 1, just look at the top of the screen, 1 by 2 and open the bracket and x plus, there is two terms, numerator and denominator, so that we have to use the bracket, separate bracket for numerator and division, separate bracket for denominator, that is 15 by x, and then you can go for calc function. I hope you can understand. So next we can move for the next thing. There are the Newton iterative formula find the reciprocal of integer root n. Hence by using that formula we are going to evaluate for 1 by 19. First we have to go for a generalized formula. 1 by 19 means it's going to somewhere like 1 by 18 or 1 by 19 and 1 by 20. General I'm taking, so that it's going to be obviously it's nearby 1 by 20 or 1 by 18, right? can take this as an initial value, and then we can go for solving the things. Before that, we have to derive the generalized formula. We know that Newton-Raphson formula is xn plus 1 equal to xn minus f of xn by f dash of xi. This is the most general formula. By using this formula only, we are going to derive. Before that, we have to convert the given problem in terms of mathematical equation. The derive Newton's iterative formula, find the reciprocal of given number, right? So reciprocal means take this as x equal to 1 by n. Because we are trying to find the 1 by n value, we are not sure about the value, so that I am taking x as to represent the unknown value. Usually we are representing x as the person x, the x value means we are representing x as for this is usually we are doing. So x equal to 1 by n. So the next stage we can take cross multiplying, we can take n equal to 1 by x. Purposely we are doing, suppose if you are really curious about why we are taking the cross multiplication, otherwise you can simply take x minus 1 by n as a 0. If you take this and just go with this and then comment the things what you are getting, what is the error we will get if you go with this x minus 1 by n. I'll give, okay, just try it, then you will end up with some error, so that you can get the better understanding of it. So I'm just cross multiplying, and then again I'm taking to the n to the right hand side. After that we'll get 1 by x minus n equal to 0. Rewriting, that is 1 by x minus n equal to 0, so that we can take this as f of x. Let f of x is 1 by x minus n. We are trying to find the roots of this equation. This is what the general equation for representing finding out the reciprocal of any number. So that from this f dash of x, you know that differentiation of 1 by x is 1 minus 1 by x square. That is, just look at the left of the screen, 1 by x, x power 1 by x can be represented as a minus 1. So differentiation of x power n is n into x minus x power n minus 1. So minus 1 minus 1 minus 1 x square. This gives us minus 1 by x square. So n is just a simply constant term. When you are differentiating, we'll end up with 0. So f dash of x is nothing but minus 1 by x square. So we have got the function as 1 by x minus n, and f dash of x is nothing but minus 1 by x square. Now we can go for solving. Xn plus 1 equal to xn minus f of xn by f dash of xn, in which we can go for substituting f of xn. Just take this f of x and replace x by xn, 1 by xn square minus n by f dash of xn, that is minus 1 by xn square. Next, right, and we can take to this numerator, that is xn plus 1 equal to 1 xn 1 by xn square minus n. Take to the numerator, this becomes minus xn square by 1. The next step, xn plus 1 equal to xn, minus of minus becomes plus 1 by xn square minus n times of xn. Just multiply inside, xn plus xn by xn square minus n xn. So xn plus 1 by So somewhere I have done a mistakes. This is not 1 by xn square. This is simply 1 by xn. Just correct it. So this is going to be xn square by xn. So that simply will get xn, right? Sorry for the mistake. N by xn. This is what the function, right? When you are replacing, I have done a mistake, 1 by xn. So you must be careful while substituting. So xn plus xn equal to 2 times of xn minus nxn. I think this is enough. If you want to simplify further, you can take xn as commonly outside. So that will end up with 2 minus n. So otherwise you can keep as it is. This is n times of xn square, right? Again, these are all the simple mistakes in xn square. So that when we take the xn square outside, n times of xn. So finally we'll end up with xn plus 1 equal to xn 2 minus nxn. If you want to keep as it is, means you can stop with this step. So you can go further, means you can go. This is what the formula we have derived for. This is the formula for finding out reciprocal of any integer. That is xn 2 minus nxn. So by using this, we are going to find the particular case 1 by, that is reciprocal of, I forgot the question, 1 by, I think 1 by 19. That, sorry, we are trying to find the 1 by root of, 1 by 19. That's all. So that if we go starting the iterations, we have to go with x1. This is based on initial point x0, 2 minus n times of x0. So the x0, since we are trying to find the 1 by 19 value, this is like somewhere lies between 1 by 18 and 1 by 20. This is somewhere lies right. I can take either 1 by 20 or 1 by 18. 1 by 20 value is nothing but 0.05. So that I am going to take x0 as a 0.05. So that the first iteration value is 0.05 minus 2 minus 0.05, whereas n value is nothing but 19, right? You can keep here. By substituting, you can use the scientific calculator by feeding this. Simply in your scientific calculator, take this x minus 15x, 2x, just feed it in your scientific calculator, so that by using the calc function, x value is 0.05, put equal, you'll get the answer. Just try this in a scientific calculator. X minus, open the bracket, 2 minus 15 times of x. By, in order to bring the x value, you can use the alpha button, that is alphabetical button in your scientific calculator. After pressing alpha and just press the close bracket, you can get the x value. So this is how you can bring it, and when you're replacing x equal to 0.05, you'll get the answer. I hope you're all getting the answer as x1 equal to 0.0525. So this is the first value. After the first iteration, we have got the answer as 0.052. We can go for the next iteration, x2, that is based on x1. This is what the foundation, right? This is what the base formula for finding out the reciprocal of any integer, in which I'm going to replace xn by x1. The next value x3 depends upon x1, 2 times of n value is, more precisely for this problem, n value is 19 times of x1, whereas x1 value is 0.0525, 2 minus 19 times of 0.0525. As I said earlier, you can make use of the scientific calculator by entering x times of 2 minus 19x and then go with the calc function. Now it will ask the x input. You can simply press 0.0525, then press entering equal symbol. You will get the answer instantly. The answer is 0.526. Similarly, when you go for the third iteration, it's based upon x2. Just now we got the x2 value. Here you can replace the x2 values, 19 times of 2 minus 19 times of x2, that is 0.0526. 2 minus 19 times of 0.0526. The answer is, just try and tell me the answer. Just try it. 0.0526. So while comparing this, second and third iterations are same. We can start with this. So the value is going to be, the solution of, that is reciprocal of 19 is 1 by 19 value is 0.0526. This is the algorithm working at the back end of scientific calculator. Just if you are curious about it, Google it, you can get this. This is how scientific calculators are working to finding out the reciprocal of any integer and also square root of numbers. This is what the beauty of Newton-Raphson method. It's a numerical methods. You can get the answers accurately. So we'll recap the things. What are the things we have seen so far? First, we have started trying to derive the generalized formula. So in the beginning of the lectures, so the second problem, I have told you to, we have taken x equal to 1 by n, and later I have taken the cross multiplication instead of taking as it is. If it is not the case, means I insisted you that we might have get some error, right? I'll tell you. If we consider f of x equal to x minus 1 by n, and when you go for the differentiation, we'll end up with 1 minus 0. So this is the f of x and f dash of x, means when you go for the generalized formula, that is xn plus 1 equal to xn minus f of xn by f dash of xn. That is xn, f of xn is nothing but xn minus 1 by n by 1. When you are multiplying minus inside, you will end up with xn minus plus 1 by n. Again we will end up with the same thing, that is nothing but xn plus 1 equal to 1 by n. It is difficult, right? We can't start the iteration because it's purely constant. That is the reason we have taken the cross multiplications. So this is the reason, instead of taking as it is, we are cross multiplying, we are converting f of x as a 1 by x minus n instead of 1 by n minus x. Okay, so these are all the things we have derived. This is just a recap, and we have applied the things and we have got this. And sorry, if you are really curious, it means this is the same way you can go for solving f of x, square root of cube root of any integers, finding out the cube root of any integers, and 1 by square root of any integers. By just take these two problems as homework. Try to derive the general or iterative formula for cube root of any integer and 1 by square root of any integer by NR method, that is Newton-Raphson method. It's very easy. If you understood the problem, means it's going to be very easy. So I hope you have enjoyed the sessions, and you can, if you have any doubts, feel free to put it in the comment box. I'll answer you as soon as possible. Okay, all the best. Thank you all. Thank you.